Like expected value, variance is another single number summary of the distribution of a random variable. While the expected value gives us the center of the distribution, the variance tells us how spread out the distribution is. Mathematically, the variance of a random variable is defined as the expected value of the square difference between the random variable and its expected value. Here, var of x is the variance of the random variable x, and x minus e of x is called the deviation of random variable from its mean, that is expected value. This formula can be simplified using the linearity of expectation and some algebraic manipulation. The reason we simplify this formula is because it becomes easier to calculate the variance of a random variable, as we will see shortly. Now, let's see how variance can be used to solve a use case to understand the concept better. Suppose we have an investment with returns that can be 2, 5 or 10% with probability 0.3, 0.4 and 0.3 respectively. We want to calculate the variance of the returns to understand their volatility. From the problem, we can see that the random variable x can take values 2, 5 and 10 with probability 0.3, 0.4 and 0.3 respectively. Recall from the previous lectures that expected value of a random variable is the sum of the product of the values of the random variable and their respective probabilities. Substituting the values of the random variable and their respective probabilities, we get the expected value of the random variable x as 5.6. Now let's calculate the expected value of the square of the random variable x. Substituting the values of the random variable and their respective probabilities, we get the expected value of the square of the random variable x as 41.2. Finally, we have everything we need to calculate the variance of the random variable x. We can substitute the values we just calculated to get the variance of the random variable x as 9.84. This means that returns are spread out around the mean of 5.6 with a variance of 9.84. Therefore, the returns are highly volatile and risky, as they can vary significantly from the mean. And that's all for this video. In the next video, we will learn about another popular distribution called the Poisson distribution and calculate its expected value and variance. Thank you for watching.